Thank you everyone for coming and listening in on our presentation tonight, learning how to take care of your sprinklers and bubblers and how to figure out what's wrong with them when they're not working and how to fix them when you do determine what the problem is. So let's go ahead and get started on the presentation. So we are going to be running through a PowerPoint presentation, and I'm going to be dropping out of it and showing you on video some of the actual components. I just think it's better to see the actual bits and pieces themselves rather than just pictures of them. We're really looking forward to hopefully next spring going back to in-person sessions on these. I just think there's a lot more value because during break and after the class you can come up and actually touch and feel and see what irrigation components actually look like and actually hold them in your hands. But we're doing the best we can at this point. So let's talk about our bubbler and sprinkler system basics. We're going to talk about maintenance, how to keep them up and running properly, troubleshooting, how to figure out what's wrong with them when they're not working properly, and then of course some good repair tips that'll help you out a lot when you do have problems. So we do have to remember these automatic irrigation systems are mechanical, so just like our cars, they need to be maintained. You've got to change your oil, and that's the thing about maintenance is you're taking care of problems before they become big problems, or you're catching them before they become big problems. You want to be paying attention to your irrigation system long before you get that big giant water bill because something's been going wrong. So installation is only the beginning, unfortunately, because without maintenance, plant health can suffer, sometimes to death. You can get clogged nozzles, you can get clogged bubblers and things like that, so you end up with hot spots in your grass. If you're using bubblers, all of a sudden your plant material goes into stress. You don't want to let it go too far, otherwise it's just a trip back to the nursery to buy a whole new plant and start all over again. Fortunately, with our summer Bermuda grass, so you can get it to recover itself just by correcting the problem and getting the water back on target. The system can deteriorate to the point where replacement is the only option. So that's the thing, is making sure you're taking care of this system. The components aren't going to become so fragile or just obsolete and things like that, where you just finally just got to say, we're just going to abandon the old system and put in a new one. That happens more frequently with the poly drip irrigation systems, and that's usually caused by lack of maintenance and bad design and bad installation. A properly designed drip irrigation system using that poly tubing, where it's well designed, well installed, and properly maintained, is a 30+ year irrigation system. And of course, important to us all, especially these days now more than ever, is water can be wasted. We want to make sure we keep all the water we can up in those reservoirs so we do have continue to have our good water supply. So there are different types of irrigation systems. Those of you that came here from somewhere else, like me, I came from the Midwest. We didn't have irrigation systems. We just let the rain fall out of the sky and everything grew pretty well on its own. So tonight we're going to be talking about those sprinkler systems. And even if you're not real familiar with irrigation, when you see the sprinkler heads pop up and all of a sudden the water comes out of the nozzles and starts landing on the grass like rainfall, it's a fairly visual system, so people kind of get the idea of what's going on with it. And then of course we do have our bubbler systems. So these are typically used, it's basically like localized flood irrigation, where you're just containing the water with those berms. You're filling up that well very quickly with water and then allowing it to soak in. So bubblers were actually what were used very commonly for plant materials before we started using our drip irrigation, which is what we talked about 2 weeks ago. So the first kind of maintenance we're going to talk about is your daily irrigation system maintenance. And that really doesn't mean you have to do anything other than pay attention. This is something when I was a contractor, when I was in charge of a maintenance division, just kept hammering into these guys over and over again. 80% of catching these problems is simply paying attention, often when the irrigation system isn't even running. So number one, you're going to look at your plants and you're going to look at your grass. So some signs of underwatering is going to be your leaves turn brown and actually curl up. And your grass is going to start turning kind of a bluish gray tinge before it actually goes to that brown color. The other thing is often when it starts getting a little bit water stressed, after you walk across it, 20 minutes later, you look at it and you still see your footprints. We actually call that footprinting. So you know you're getting pretty tight on the water at that point. Some of your signs of overwatering is your new leaves actually droop in the afternoon on your plant material. Many people will see that and they assume it's not enough water, and they actually start increasing the water they're giving the plants. The best way to figure out how much water you've got in that soil is by using a simple soil probe. Our soil, when it's dry, is the consistency of concrete. So a long screwdriver for your grass, because you're only looking to see that water go down about 6 to 10 inches. That screwdriver will penetrate very easily through moist soil. It will not go into our dry soil. Now for your shrubs and trees, you're just going to want a longer metal rod of some sort. You can buy soil probes, and actually if you look into the Maricopa County Cooperative Extension Office, that's where the master gardeners operate out of. They make nice pre-made 3-foot long soil probes for sale to the public. If you go looking at irrigation supply stores for those long soil probes, they sell the big professional ones that can be taken apart. They're made out of stainless steel and they cost $200. You're not going to buy one of those. I believe the last cost I heard was somewhere in the neighborhood of $10 or $20 for the ones that a master gardeners sell. And if your grass is starting to smell musty or it's squishy when you're walking across it, I've actually seen lawns overwatered to the point where walking across them it feels like a waterbed. So you should be able to pick up on that at least when you're doing the mowing. The other thing you're going to want to do is actually look at the ground. Leaks are easy to spot. So you're just going to look for those washed out spots. Now here, this is actually a drip irrigation leak. The system isn't even running, but you can see that washed out hole and all the soil has been pushed up on top of the granite there. But you'll see this in your lawn areas too, or this could even be piping for a sprinkler system. It's just running through a planted area before it gets to the grass itself. So look for those washed out spots. Even with the system not running, you're going to get used to identifying and knowing exactly what that is. You know you've got to dig it up and do a repair at that point. The other thing you want to do is look at your hardscape. We do have minerals in our water. We don't put them there just so people can sell you water softeners. Geologically speaking, that's what's in our water. We could remove it at a utility scale at our water treatment plants, but I don't think you'd like your water bill very much if we did that, because it would be very, very expensive. But you're going to be looking for the minerals, especially the calciums and salts, that are going to stain your sidewalks, driveways, pool decking, and patios, because after the water evaporates off, those minerals get left behind. And also look at your walls and fences. Now in this case, this is a commercial install, so those are the rotary heads. Those are the ones where the water rotates back and forth in a stream, and they're just out of adjustment. So they're arcing too far, and they're spraying the water up on that nice colored block wall. And it's a colored block wall, so they can't even just repaint it and call it good. Well, I suppose they could, but if they don't fix the problem, that means they just have to keep repainting the wall over and over again. If they want to maintain that nice colored block that they spent a lot of money on, they're going to have to use something like a muriatic acid wash to get that down. And once that acid washes down into the grass area, you're going to have some brown grass. So that's why modern landscape designs make sure you don't have that grass right up against any hardscape. There should always be a little bit of a buffer with some decomposed granite area in between any of your hardscapes, because sprinklers do get knocked out of adjustment. So for monthly irrigation maintenance, and this goes for any type of irrigation system, is you want to actually start at your controller or your timer. One of the reasons why you do this is you make sure that the program is appropriate for the season. These standard irrigation controllers do not change according to the weather. They keep running that program you put in there forever until you change it. Now, there are new controllers out there referred to as smart controllers that actually measure the weather every single day, and they respond to that and they change your watering based on what the actual weather's doing. I believe it's early December we're going to be doing that class. We're going to show you some good smart controllers. But really what you want to do is you want to turn the system on in the daytime, especially with your sprinklers and also with your bubblers where you've got that standing water waiting for it to soak in. Running in the daytime, you're going to lose that water to evaporation. So you actually want to run those sprinklers through the middle of the night. If you're new here from the Midwest, don't panic. We don't have the problem of running sprinklers in the middle of the night like they do back there, where you're going to cause all sorts of fungus and bacteria and things like that. We live in a desert. We're just very arid. That's not going to happen unless you're severely overwatering. So don't go out there at 3 o'clock in the morning when your sprinklers are normally running with a flashlight trying to do your system inspection. For semi-annual maintenance, and this is what I'm doing here is I'm actually going through the big items, and then we're going to talk about the specific things to sprinklers and bubblers here. But about twice a year, if your controller uses a 9-volt backup battery, you want to replace that every 6 months. Do check with your controller manual. Some of your high-end controllers actually provide a trickle charge, so you use a rechargeable battery in those, and every 6 months is too often to change it if that's the case. If you look in your controller manuals for the ones that use a regular 9-volt battery, they say to change them once a year. They don't live in Arizona, so our heat really drains out the juice on those batteries. And what those batteries do is they maintain the program in the controller in the case of a power outage. They won't run the irrigation, it's not enough voltage, but then when the power comes on, you won't have to go out and reprogram your timer. Another thing you want to do is about twice a month is go ahead and inspect your valve boxes. We go to great lengths to hide all these irrigation system components. They're not pretty, they're not plants, they're not flowering bushes, they're not trees that provide a shade that people like to look at. They're very mechanical and kind of engineering looking, so we go to great lengths to hide it. 99% of your irrigation system is below ground, and we like to bury those valves underground in boxes so we can get to them later. And even then, we try and often put those boxes in areas where they're not so visible. So about every 6 months, turn your system on, lift the lid off that box, and make sure you don't have any small leaks going on. You may not have a giant leak that's flooding that side of the yard. It may not be enough to affect your water bill because you're only being billed in 1,000-gallon increments, but you really need to throw a couple hundred gallons of water a month into the ground where there's no roots of any plants or any lawn. So that can save you a little bit of water right there. And over the course of a year, that's actually a couple thousand gallons of water. Go ahead and clean out any excess dirt. These valve boxes always get dirt migrating back into the boxes, and that's because we put a whole bunch of valves in the box rather than just one, like we're going to show you on this photo here, which actually is a drip valve. That's because you're seeing that filter there. And let me see if I can do my little, whoops, sorry about that. This mouse wheel on this particular mouse is very, very sensitive. There we go. It's over here now. You move it, huh? Well, fine. We'll just do it this way. Where's my pen? Okay. So this is a drip valve, so it's got this filter here. You're not going to see that on a sprinkler valve. The orifices on the nozzles are big enough to pass anything that gets through the water system. You do want to see that on your drip valve, and that's actually a good way when you're looking in your box. If the people put it in correctly, your sprinkler valves will not have filters, but your drip valves will. But you're also going to want to check these wire connections here and make sure you're using waterproof wire connectors. And all too often we see out there that, oops, I should have erased that. You move my little toolbar to where I can get to it easy. There, I've got it. Okay, let's erase everything. This is being hinky. I apologize for a little technical difficulty here. They're all annotations. There we go. Boy, it just was not popping up the window correctly for me. Okay. Oops. Let's go back there. So unfortunately, way too many people are using just standard wire nuts down there. And the ends of the wires inside those standard wire nuts is exposed copper. Inside your valve box, it's always damp. It's underground in a box with a lid, so there's always a good high moisture content in there, and being damp is normal. Standing water is not good. That means you do have a leak. So what you do want to use is some type of a waterproof wire connector, and I'm going to pop out of the presentation here for just a moment. There we go. So typically many people are using this multi-strand wire that has individually insulated wires. So with the standard wire nut, you're just clearing off some of the insulation at the ends of the wires and twisting it on there and making the connection. But inside that valve box, you're going to get the corrosion on that copper of the wire. And over the course of time, because it's a low voltage signal coming from that timer, it's never going to reach the valve and it's not going to turn on. So they do make waterproof wire connectors that are very similar. They are a wire nut, but they've got these little flanges on the bottom. And let's see if you can see those. My autofocus on my web camera doesn't do a very good job, unfortunately, but there's actually silicone inside there. So you would put that on there and that would make a good waterproof wire connection. When we teach the professional contractors how to do their installs, we tell them not to use these, not because they don't work, but if somebody does have to replace a solenoid, when they take this off, put the new solenoid back on, they're going to reuse this, and it doesn't have any silicone in it anymore. It's just a standard wire nut. So we actually tell them to use this type of waterproof wire connector. So these are your larger, thicker wires that you'll see on a commercial irrigation system. Oops. So you bring the wires up through and you twist them together. There's a copper collar you crimp on there. And then you have a cap that's filled with silicone. This one's empty, so I can use it as an example. And then you just snap that together. Notice I'm not snapping it all the way together, because once you do that, you can't get it apart. But what that does is if anyone has to replace that solenoid or do a repair, it forces them to cut the old wire connector off and they can't reuse it. Then they have to put on a new wire connector. Either way works. Just make sure when you're doing your repairs, if you do use those types that are wire nuts that are just filled with silicone, use a new one when you do any kind of repair. Don't reuse it. For annual system maintenance, you may want to consider when that backflow preventer was last tested. This is the preferred type of backflow preventer for irrigation systems. It's called a pressure vacuum breaker. Let's see if I can bring up my annotate node here so I can draw a little line around it here. Just going to put it all the way back over there again. Okay, let's put it here where I can reach it. Got my pen. So you'll see this actually has a shutoff valve here. So if it's perpendicular to the pipe, it's in the off position. So this particular one is shut off. If the handle is parallel to the pipe, it's in the on position. There's supposed to be another handle for a shutoff valve down here. It's just been removed. But these have test ports on them. So these are actually the preferred way because they can be tested to make sure they're functioning properly. So let me clear these real quick so I can draw some new lines. Yep. Okay, get my pen back. There we go. Okay. So if the water tries moving in a backwards direction, so what these do is they make sure the water, once it goes in your irrigation system, can't come back into your drinking water. There's a valve here that opens this way. So that creates an air gap here underneath this cap to create an air gap. And there's also another check valve down here that shuts to seal off that pipe so that water from the irrigation system cannot go back into your drinking water system. So that's a good thing. Now we require irrigation systems that are on dedicated landscape meters. Whoops, sorry about that. To have those tested every year. We don't ask homeowners to do that. There's just too many of you out there. That's just way too much paperwork for that group. Not only that, it's actually probably overkill for what you need for your smaller irrigation systems, but maybe about every 5 years you want to make sure you get that thing tested. Contact your water department and they will be able to provide you with a list of the certified testers. Those backflow testers are certified with the state of Arizona. Okay. What you want to make sure you're not doing is using the wrong type of backflow preventer. So this particular backflow preventer is what we call a manual anti-siphon valve. So there is a little check valve down here where if the water's trying to run backwards through the system, it opens up and creates an air gap. The problem is it's got irrigation valves downstream that are shut off, which means that little check valve will never open up and allow that air gap to be sealed. So if you've got one of these and you've got your irrigation valves down underground in the boxes like I'm showing here, you want to get that replaced with that pressure vacuum breaker. Being code is probably the least important reason for you to make sure you're doing that. It really is about the safety of your drinking water. Okay, so let's talk about specific things for bubbler irrigation maintenance. We wanted to cover the big things that are done for both systems, so you don't want to repeat them. So let's talk about bubblers and what they are. Some people still use them, and there are good reasons to still use them. So basically, like I said, they're miniature or localized flood irrigation systems. They're very useful for very large, very high water use plants like citrus trees. So those of you that have looked at our landscape watering by the numbers brochure and looked at those gallons needed for a tree based on the size of its canopy, when you're looking at a 20-foot tree, I think is the maximum size we show, it shows something like 265 gallons of water. Now, if you've got desert trees, mesquites and palo verdes and things like that, they don't need nearly that much water, but you're watering citrus trees for a completely different reason. You want that nice juicy fruit. So don't short your citrus trees water when they're producing that fruit. Otherwise, it's going to be all dry and pithy, and you're just going to have a bad year for crop out there. So it takes an awful lot of emitters to deliver that 260 gallons of water per irrigation event with drip irrigation, whereas bubblers deliver the water in gallons per minute rather than gallons per hour. So they fill up those wells very, very quickly, and then you just allow it to soak in. So for monthly bubbler system maintenance, you're going to turn it on and actually walk around and look at it and make sure the bubblers are flowing at the proper rate. So that's what an umbrella flood bubbler looks like. Now, some of these are preset, and this particular one in this picture is preset, and it is a pressure compensating bubbler. That means within a range of pressures, it always puts out that rated amount, which is very important. So now you know exactly how many gallons per minute are coming out of that. So a lot of people like the adjustable ones, and I'll show you what those look like real quick here. Let's do a stop share. So a lot of people like these, whoops, there it is, like these adjustable bubblers. So you see this little top here that I can turn. I can close it down so less water comes out. I can open it up so more water comes out. The problem with that is it depends on pressure, how much water is going to come out of there. And if you have a whole series of these on the line, your last bubbler is always going to put out less water than your first one. The other thing is you have no idea how many gallons per minute is coming out of each one. And when we tell you you want to give this size tree X amount of gallons, if you don't know your gallons per minute, you cannot make that translation. So we do recommend using the preset pressure compensating bubblers. The other thing is look how easy I can adjust this. If you've got something around your yard that can be turned, and you've got kids, boys in particular, I speak from experience, we will find it and we will turn it. You'll say, oh, that didn't do anything, but now the next time your system runs, it's open much further than you had it set for, and now you're flooding half your yard instead of containing it. So the pressure compensating bubblers are preset. There's no adjustment screws or no things to turn on there. They just are what they are. And I think this one I'm showing here is 1/4 of a gallon per minute. So you can get them in 1/4 gallon a minute, 1/2 gallon a minute, 1 gallon a minute, and so on. There are also adjustable bubblers out there that require a screwdriver to make those adjustments, but you still have the problem of not knowing exactly how much is coming out of each one. So you don't really know how many gallons of water you're giving your plant when you run your system. So let's get back to sharing. There we go. Okay, so really that's only going to take a couple minutes, walk around your yard and make sure it's okay. Definitely go ahead and, there we go, check for leaks or damage to your bubblers, risers, or piping. Make sure the water doesn't overflow your basin. So for my particular lemon tree, I'm not that fussy. I don't require flagstone or bricks to make those berms. I've just got dirt berms out there. And occasionally over the course of time, they do get compacted. So every once in a while, I got to go bring in some more dirt and build them back up again. Also bury any exposed PVC. And if you've got any exposed PVC, it gets what we call sunburnt very, very quickly. I'm not going to bother popping out of the presentation for this. I think you can still see my video in a small window. But if you see the color of this PVC coupling I have here, I laid that out in the full sun in the summer for about 2 weeks to turn it that color. So that's going to become brittle, and it's a leak waiting to happen. It's going to break, and you've got a giant flood out there. So for semi-annual bubbler maintenance, so about twice a year, what you're going to do is make sure the basin is the proper size for the plant material. So what we're talking about here is where you want to water. When that's a brand new first installed tree, you want to water right at the base because that's the only roots the tree has or the shrub has, whatever the size container it came from the nursery in. But what you want to do is do everything you can to encourage those roots to start growing out deep and wide. The deeper you get your roots, the better these high water use trees like citrus trees are able to handle our hot summers. So that's where you run into people seeing a lot of trouble with their citrus trees. They still only got 3 2-gallon per hour emitters on it. So they're only giving it about 6 gallons of water 3 times a week. It's never growing any roots down deep where they should be. And it just makes it get a lot more stressed in the summertime heat that we have. So one thing you have to always remember when you're running your irrigation system, you're not watering plants. That's not the target for your water at all. What you want to water is roots, not your shrubs, not your trees, not your grass. Focus everything you do on watering the roots. So in this particular case, Let's see if I get a little quicker at this. In the beginning, making this small little well here for this tree is fine, but as time goes on, instead of continuing to move these out, actually we don't want to water in this area anymore, especially with citrus trees. If you're watering too frequently and keeping that spot where the trunk becomes, or the roots become the trunk of the tree, you can end up causing what's called crown rot. We're talking about the root crown, not the crown of the canopy. So what you do want to do is over the course of time, you want to actually construct, sorry about that, a second set of berms so it looks like this. So now what we're doing is we're watering out at the edge of the canopy, which is where you want to water. And if you think about it, it makes a lot of sense because when people are ever out in nature, you're not around any buildings and it begins to rain, people naturally go under the trees because it's drier there. Because the tree is taking a lot of the rainfall that hits the canopy and shedding it off the edge, what we call the drip line of the tree. That's where you want to focus your irrigation. So what we've done here is we've constructed a second set of berms. We've taken the bubbler out from here and moved it over here. And I've got an overhead view to make that a little bit easier to see what we're talking about. This does not want to pop up today. What's going on with this thing? Okay. So looking at it from overhead, we call this a donut. So what you want to do is water the donut and not the hole. So you'll see that yellow line, that yellow circle on the inside, that was the original berm when the tree was first planted. And then you'll see that second yellow circle out at the edge of the canopy. So we've created that donut. So we're watering the donut and not the hole. Okay. That's pretty much it for bubblers. Those things are pretty simple. There's not a lot of components going on there. So they're fairly durable. They're on PVC pipe, but they can still get damaged. So you want to keep an eye on them. So let's talk about lawn irrigation maintenance or sprinklers that we use out there. So lawns, they're not the highest water use plants in the landscape. If you do have citrus, those are actually higher water needs than lawns, but they're one of the higher water using plant materials we like to do. That doesn't mean lawns are bad. Lawns are the only plant material that will tolerate foot traffic. So if you want a play area for the kids, or you've got a dog and you want a small play area, and of course what dogs normally do on grass anyway, having a piece of lawn in the backyard is perfectly appropriate. You do want to make sure though, with proper management of that water and proper maintenance of the system, you're only applying the water that's actually needed. So let's talk about, we got a new category here with weekly sprinkler maintenance. And what you're going to do is generally after you mow, you want to turn on that system for just a minute or two and make sure the mowing didn't damage any sprinkler heads. We often refer to these as geyser checks. So here you'll see this was a home in Gilbert where I was doing a water efficiency checkup, and when I turned the zone on, saw that nice 30-foot geyser of water coming out of the ground there. And when I show people this picture, they all say, wow, look at how much water he's wasting. Then I say, look at the picture. Where's the water landing? It's landing in his pool. So he's not necessarily wasting any water, but he is causing some other problems out there. Number one, he's not getting the coverage in that area from that sprinkler head that normally waters that area. He's also lost some pressure on the system, so the other heads aren't running at their full distance anymore. So you're going to start seeing some stress in the grass. So even though it's filling his pool, instead of just wasting water, it is something you really want to get fixed. Okay. So another thing you want to do for weekly sprinkler maintenance is make sure your nozzles are directed properly. They do get knocked out of alignment in some cases, simply by using our string trimmers, what we call weed eaters out there. So here we've got a sprinkler head and it's right up against the patio. So here's our patio down here. And we've got a little sprinkler head here with a half pattern nozzle. What we want to make sure doesn't happen a real pain. Apologize for this. It will not let me bring up my eraser, the little window to clear all annotations. There we go. Technical difficulty today. So we call that edge control. What you don't want to do is have that nozzle out of alignment. So now you're watering your patio and there's a section of your turf that's your lawn that's not getting watered anymore by that sprinkler head. And of course, watering the patio does nothing for the lawn. And if you've got a nice brick or flagstone patio, now you've got that calcium staining going on there, which is not very pretty. So for monthly sprinkler maintenance, you're going to turn on the system and you're actually going to take a closer look and walk around and look at all the individual heads. And you're going to check for any leaks or damage to the heads, risers, or piping, because sometimes the riser will develop a leak. That's how the head is mounted to the pipe. We'll show you what that looks like in a little bit. And you're not going to get a geyser when that happens. It's just going to start slowly eroding the soil away from around the sprinkler head. Left like that long enough, sooner or later it's going to erode enough that you're actually going to find a hole in your lawn. But make sure you don't have any water bubbling up from underground on that sprinkler head. It should all be coming out through the nozzles. And also, every once in a while, actually run your sprinklers the same amount of time you would normally run it, and make sure you don't have any runoff. These sprinklers apply the water more than 10 times faster than our soil will absorb. So if you're trying to water deeply, to do that every 3-day watering, you can't do it in one shot. So you're going to do what's called cycle and soak programming. So if I need 15 minutes of run time, but I can't water more than 6 minutes before I have it running off and down the street, what I'm going to do is I'm going to set that timer for 5 minutes, each of that station for 5 minutes, but then I'm going to give it 3 start times an hour apart. So I cycle 5 minutes and soak an hour, cycle 5 minutes, soak an hour, cycle my last 5 minutes, all my water's in the root zone of the grass, not running down the street. That allows you to water deeper and less often. Watering the patio does nothing for the lawn. And if you do still have a lawn in your front yard, all that water running across the sidewalk and down the street, that's water you're paying your water department for that's doing nothing for your lawn. And I know we have transportation issues in the valley, but I assure you, watering streets do not make them grow. They actually make them erode faster, which means we have to repair them more often than we should. So the other thing for monthly sprinkler maintenance is make sure the spray pattern isn't distorted or have gaps. Your standard spray nozzle is just a slit where the water comes out, and if there's a little bit of debris in there, it's not very large, but you'll see as it moves out into the pattern where that sprinkler head covers, that gap gets bigger and bigger and bigger where you're not getting any water applied. And we actually call those fingering nozzles because very often you'll end up with just fingers of water coming out of there. Also make sure the sprinklers pop up above the grass. I don't know why, but people insist on buying those little 2-inch pop-ups and they mow their grass at 2 inches high. And before they mow again, that grass is now 2.5 inches high. So what's going on here is all the water is being blocked by the grass right here. So now we're starting to see some stress out here if we're real tight on our water management. And this area over here starts getting real swampy. So what you want to do is make sure that you're using a sprinkler head that pops up 4 inches in height. That way it's always going to clear the grass and you don't have to worry about that. We're going to actually show you when we get to some of the repair stuff how these sprinklers are actually attached to the pipe and actually a better way to do it. Okay. The other thing you want to do is make sure your heads are perpendicular to grade and at grade level. So you want to make sure they are nice and straight up and down. And you also want to make sure the very top of that head is even with the soil surface. You don't want it sticking up too high. You're going to catch it with your lawnmower. But if you have it too low, every time that stem retracts, it's going to drag dirt across what's called the wiper seal. And I'm sure most of you that have lawns and sprinkler systems, you've seen that sprinkler head before that doesn't pop back down after you're done watering until you go over and tap it with your foot. That sprinkler head is too low and you've scratched up that pop-up stem and you've ruined your wiper seal. So it's actually time to replace that head at that point in time. It's starting to work a little better now for some reason. Okay. So you don't want your heads tipped like this because this is causing us a serious problem here where we're not getting the full distance for coverage we need over here. And we're also not getting any of our close-in watering over here. So we're actually spraying probably too far over on this side. So we don't want to be spraying outside the lawn either. There we go. Okay, let's get into some troubleshooting and then some repair. It looks like we got about 20 to 25 minutes left if we were 20 to 30 minutes left. Want to make sure we definitely have time for any questions that you have. And again, if you do have questions, type them into the chat box. Queen Creek and Chandler people are pretty good about being able to answer those questions. If they run into something they can't answer, they're going to interrupt me and make sure that we get all your questions answered. So troubleshooting, even with the good maintenance regimens, things go wrong. You take care of your car, you change your oil, you rotate the tires, and then the air conditioner dies on you. That's just the way the world works, unfortunately. So the first part of this troubleshooting part, named Why is my controller acting so crazy? And this comes from my time working at that Rainbow Technical Service, where all the people across the country were calling us because they had problems with their irrigation. Things weren't working properly. And they identified their entire irrigation system with that timer hanging on the wall because that's the part they can see. So that's what they always assumed what the problem was. Where in a lot of cases, it's actually sometimes often a programming error or the real problem is somewhere else in the irrigation system. So one of my favorite calls was from a sweet little old lady who was convinced her controller was under some sort of demonic possession because her 3 sprinkler stations would run through and then they'd start up and run through the 3 stations again, and then they'd start up and run through the 3 stations again. So obviously she felt that was a malfunctioning timer, but this was really a programming error. She tried to outsmart her timer and she lost. She put in extra start times. She thought those start times were individual start times for individual stations. There is one Rainbird timer out there where you do assign individual start times to individual stations, but they're not real common. Generally speaking, these start times are what we call cycle starts. One start time runs through the cycle of all stations in that program, one after the other. So in this case, if you want to water Monday and Thursday, and you got 3 stations that you want to water for 15 minutes, if you wanted to start the cycle of those 3 stations, you put in one start time of 5 a.m. This is the most common programming error we see. So now what's going to happen is on Monday morning at 5 a.m., it's going to water station 1 and run for 15 minutes. It's going to move to station 2 and run for 15 minutes, move to station 3 and run for 15 minutes, and then it will stop. But unfortunately, she put in the extra start time thinking that she needed to start station 2. But in reality, she started a second cycle of those 3 stations. And of course, she had the 3rd cycle in there. So now instead of watering her grass 15 minutes, she was watering her grass for 45 minutes. Another good one is the irrigation runs at strange times. This also could be a programming error. The displays on those controllers very often is very small, and it's hard to see the difference between AM and PM. But if you get those mixed up, either with your current time or a start time for a program, it's going to come on 12 hours different than what you thought it was. If it just comes on in some weird random time, more than likely what happened is there was a power failure and you didn't replace your backup battery when you should have, and now the controller is running what's called the factory default program. All of your manufacturers that have the types of controllers that need that backup battery will always put in a default program in the A or number 1 program, and they set it to water every day, all stations for 10 minutes with 1 cycle, and they'll usually put in like a 5 or 7 a.m. start time for that default. But when the power comes back to the controller, it thinks it's midnight. So 5 or 7 hours later is when your sprinklers come on. So what you want to do at that point is go ahead and reprogram your timer and then make sure you put in a new backup battery. Another problem people will see is the controller won't respond to any of the buttons, no matter where you turn the dial, how hard you press the buttons. Obviously a dead controller, not necessarily so, because very often what can happen is they've just received a power surge. The early controllers way back in the 1980s and 90s, power surges would kill these controllers. They're much more durable now. So basically what's going on is that little microprocessor in the controller is locked up, and when our computers get locked up, we reboot them. So all you're going to do, there's no Control-Alt-Delete keys on a controller, so all you're going to do is remove the power. Shut off the circuit breaker if it's wired to your breaker box, or unplug it if that's how it's set up. If your controller uses a backup battery, make sure you take out the battery. It's designed to hold that information on that chip, and it may not reset itself. About 30 seconds to a minute, power it back up. In most cases, it's going to start operating fine for you again. If it was a strong enough power surge, it may be truly dead. If it's not under warranty, it's time to buy a new controller. That would be a great opportunity to consider one of those smart controllers that adjust themselves all on their own based on the weather much more often than anyone would ever adjust their controllers. Another great one is one station won't stop watering. The cause on this could be a programming error. That station just doesn't seem to ever shut off. Be very careful with how your controller programs in runtime. So some of your controllers, when you're working on drip and you're programming in hourly increments, it'll say HR, or the word hour. Most of your controllers out there, though, if you wanted 3 hours of runtime on something, it would look like 3 o'clock, 3:00. So this was another great one with a Town of Gilbert resident that I helped out many years ago. His water use went sky high and his grass was underwater. I opened up the controller and I said, well, there's your problem. And he said, what? I'm watering for 3 minutes and 12 seconds. 3:12. I said, no, you're watering your lawn for 3 hours and 12 minutes. Always look for the easy things first. Don't start digging things up until you really need to. It could be a valve failure, where it's what we call a stuck-on valve. So what you want to do is turn the controller to the off position. And if the valve is, if the irrigation is still running, the problem is in the valve and has nothing to do with the controller. So we're going to actually teach you how to troubleshoot and repair an irrigation valve tonight. Another one is one station won't water. The cause on this, again, check the easy things first. Could be a programming error. You forgot to put in runtime for that station when you were putting in your program to the controller. If it doesn't have runtime, the controller isn't going to run it. So it could be a failure, either an electrical failure, the wiring going out to the valve, the solenoid on the valve. We're going to cover those. Now, even though these valves are getting an electrical signal from the controller to open, there's not a motorized gate inside there. They're using the water itself to push open that diaphragm and then push it back closed when it's time to stop running. So it could be what we call a hydraulic failure. So what you're going to do in this case is check your programming first. You're still standing up, not muddy and not sweaty digging a hole. And go out and manually actuate the valve. All your irrigation valves have a way to manually turn them on independent of the controller. We're going to show you how to do that when we pop out of the presentation in a moment here. If none of the stations will water, once again, programming error. You were in a hurry and it slipped your mind, you forgot to put in a start time for that program. Even though you've got runtime and run days in there, without a start time, it never starts that program. Could be that electrical failure or a hydraulic failure, so definitely check your programming first. Check your rain sensor if you're using them. Rain sensors do not know the difference between rainwater and hose water, so if somebody accidentally got it wet with a garden hose, it's going to think it's doing its job and not allowing those valves to actually turn on and run any of your irrigation. Most of your newer controllers that have rain sensors installed have a little bypass switch on there, so you can temporarily bypass it and see if that's what's causing the problem. Manually actuate the valves. Find out if the problem is electrical or hydraulic. So if my valve doesn't open, step one, is it electrical or hydraulic? Manually activate the valve. If the valve opens, the problem is electrical. If it doesn't, the problem is hydraulic. So what I'm going to do here is I'm going to show you a little diagram of a valve, and then we're going to pop out of the presentation and show you an actual irrigation valve. But we're going to go through the symptoms first. I apologize. Been a while since I've done this particular one. If it's an electrical valve problem and the valve won't open, check that wire connection. Make sure nobody's using standard wire nuts out there. Pull that wire nut off and you see all that green corrosion on those wires. Cut back to clean wire, reconnect it, try it, see if it works. Number one electrical failure we see in residential irrigation systems just because of those wire nuts. It is actually a malfunction on the controller where it's the power source for that particular, the switch for that particular terminal no longer provides voltage. Those of you that know how to use your volt and ohm meters, you're going to be looking for 24 to 30 volts AC between the common and that station terminal. If it's 0 when the controller says it's running that station, hopefully you've got some unused terminals out there where you can just move that wire over to one that does function. Could be the wiring between the controller and the valve is damaged. Somebody was doing some digging and they cut your wires. It's unfortunate. It's more difficult to find. It's easy to find where somebody broke one of your pipes. Look for the big wet muddy hole. Try and find where they cut the wire and you're now leaking 24 volts of electricity in the ground. It can be done. A good quality trained irrigator, not what we call Chuck in a truck, just because he has a truck and a lawnmower doesn't mean he's a good trained irrigator. The good ones know how to use what's called a ground fault locator. He can find that exact spot of that broken wire and repair it for you. Or it could be the solenoid itself is bad, and the solenoid is the part on the valve where the two wires come off. And again, we're going to show you a real one in just a moment. If the valve won't close and it's electrical, it's a programming error. It could be a failure of the controller on the other side, where even though the controller is not running, it's still sending voltage to that terminal. It's very rare, but it can happen. So here we've got a diagram of what that wiring looks like. This is AC volts, not DC. So you don't have a ground wire or anything like that. So you've got your individual terminals for your stations, 1, 2, 3, 4. Each valve, that solenoid has 2 wires. So one wire for valve number 1 is connected to terminal 1, same with 2, same with 3. Then you've got this other terminal over here marked C, COM, or common. That wire is connected to one wire of all the solenoids on the valves. And honestly, they're not usually individually done like that. They will usually pull the wire from this one here and the wire from that one here and just use that one connector. So let me erase these real quick because I want to do another drawing here. Okay. So now if the problem is only affecting station 1 and you know it's electrical, because when you manually actuate the valve at the valve itself, it does turn on. So now what we're going to do, if it's only affecting number 1, it's a broken wire here, it's a bad wire connection here, or it's a bad solenoid on this valve. Very, very simple. If it's affecting all of the valves, it's a cut in the wire on your common wire, or it's this bad connection here where they're all tied together. And that's pretty much about it. It's pretty rare to have 3 solenoids die all at the very same time. Normally only go one at a time, and they can go bad, and they do need to be replaced on occasion. But normally when an irrigation valve no longer opens up, that's the first thing people do is they replace the solenoid. They notice the wire coming from the timer is all green and grungy. They clean it up, they connect it, and lo and behold, it turns on now. And then they take that perfectly good solenoid they just removed and throw it in the garbage. If it's hydraulic valve problems, if they won't open, the water could be shut off. Look for the easy things first. Maybe you had a broken sprinkler head and your neighbor noticed it and said, wow, he doesn't want a flooded yard, and shut your water off, and they just forgot to tell you about it. Could be dirt or debris in the valve. If the valve won't close, there's dirt or debris in the valve, or there's a hole or tear in the diaphragm. So let's look at a diagram of a valve, and then we'll drop out and show you a real one and what it looks like on the inside. So let me get my little drawing tool back up here. Okay, so the valve is always under pressure. The water's always in here, and it's always trying to push the diaphragm up. The diaphragm is this green part here. So it's always trying to push up on the diaphragm, but there's also water in the top chamber of the valve pushing downward. So there's more surface area on the top here, the same pressure that holds the diaphragm closed against this seat. Here's your solenoid, and that's just a little electromagnet that lifts this plunger up and then lets it drop back down when it's done running. So what happens is when the timer sends a signal to the valve, it opens up this port right here, and the water from the top chamber goes out the top side of the valve downstream. Now there's less pressure up top here, and now the water itself is what pushes that diaphragm in the up position. Let's erase those real quick and show you what it looks like at that point. Oops, I didn't get rid of my rotation bar there. So here we go. That's what it looks like when it's open. Drawing tool back here. So now the diaphragm has been pushed up, and it's always trying to refill that top chamber and regain that constant pressure, but it's still bleeding out through that open port underneath that solenoid. Now when the timer stops sending a signal to the valve, this plunger drops back down, seals that port. This chamber refills, get to full pressure. This is a little spring that's in there. We're going to show you. That just helps get that diaphragm moving back in the downward direction once it gets to equal pressure. So it will close back up against the seat and stop that irrigation from running. So I'm going to drop out of the presentation here and show you a real irrigation valve, because most people are terrified of valves. You replace sprinkler heads, you replace drip emitters, all that sort of stuff, no big deal. But when it comes to a valve, it's like, oh gosh, I better call a professional. Now, like I said, the solenoid is the part with the two wires that come off. You'll see just one of mine is broken because I've been carrying it for years doing these classes. Many of your modern valves will have a little lever there that says on and off. When you're running the irrigation from the controller, you want that in the off position. But when you want to manually turn on the valve independent of the timer, you turn that about a quarter turn. We've lifted up that plunger inside there and opened up that port. So now the diaphragm pushes open and the water goes out into the zone. Many of your valves, even if they have what we call that internal bleed, they also have an external bleed screw here, this little black screw. If your valve doesn't have the ability to open up by turning the solenoid, it definitely will have one of these. And what we do is we open that up about one turn, and you'll see water kind of spitting out of there. We call that an external bleed. That again relieves pressure above that diaphragm. Now the water underneath there can push it open and the water goes out. Some of your valves may have a larger knob in the middle. We call that a flow control. That will control how far the diaphragm is allowed to open. In most cases, you're going to leave that wide open. So first what you're going to do is you're going to turn off your water supply. And I'm going to go ahead and take off the solenoid here real quick. And it's kind of hard to do here. There we go. Now, if your valve allows you to open up the valve by turning the solenoid, that spring-loaded plunger in there is not going to fall out. If your valve doesn't allow you to manually open the valve by turning the solenoid, that plunger will drop right out and into the valve box. You'll see it's just got a little plunger inside there. I'm going to take off the little handle for turning it on. And then you'll see a ring of screws around there. I've taken most of them off so I can take it apart very quickly in these classes. So I'm just going to undo these last two screws real quick. And I can feel that little spring pushing up on me. There is a spring in there. Don't worry, it's not going to hurt you. It's not a big one. So there's the little spring there. We're going to remove that. Then there's your diaphragm. So that's what closes against the seat when it wants to shut off the valve. So if you do have a hole or tear in this diaphragm, it can never refill that top chamber to equal pressure and it doesn't shut off. So what you're going to want to do is if you've got a problem with your diaphragm, bring it with you when you go to the irrigation supply store. Once you show them the diaphragm or just take a picture of the valve, they'll know what you need. They'll make sure that you get the right diaphragm to do your repair. It's just that simple. That's all there is to an irrigation valve. Next minutes, we're going to get into talking about troubleshooting our bubblers and our sprinklers. And rather than going through all those slides, I'm probably just going to run through them real quick. Nope. Okay. There we go. Oh, why aren't my pop-ups popping? Nozzles can get clogged up. You know, sometimes dirt and debris gets into the water system. It's very clean when it leaves the water treatment plant. But how many miles of pipe did it go through before it got to your house? And how old is some of that pipe? So all you're going to do is remove the old one, flush out the system by holding that little pop-up stem up and turning it back on for a minute, flushing out any other dirt that may be in there, and install the new one. I'm going to run through these real quick and then I'm going to pop out and we're going to show you what these sprinkler heads look like. For new systems, I go so far there. Okay, I guess I just did the clogged nozzles one. Okay. So what I'm going to do is I'm going to pop out of here and then we'll talk about these new systems here as far as why don't they pop up at all, why you don't seem to have enough pressure. So I'm going to grab one that's pretty easy to remove. So here we got a sprinkler head and it's got a pop-up stem. And there we go. This is you can see the little slit where the water comes out. So when it comes to removing a nozzle, you're just going to unscrew that. And there should be a screen inside there. These nozzles do come with screens and you want to make sure you use them. So while you're holding this stem up, you want to turn the system back on and flush out any dirt or debris. Now when it comes to replacing the nozzle, you can get them in different patterns. quarter circle, third circle, half circle, 3/4 circle, full circle. You can also get them to throw different distances, 8 foot, 10 foot, 12 foot, 15 foot. And then if you see on there that little metal screw in the middle, that's called a radius adjustment screw, but don't use that if you're reducing it more than one of those next steps. So if you really only want the water to throw 12 feet, buy a 12-foot nozzle. So then what you're going to do is you're going to put that new screen in, you're going to screw your nozzle back on, and it may not line up exactly in the same orientation as your last one. But most of your new sprinkler heads allow you to turn that whole pop-up stem because you want to make sure that nozzle is nice and snug on there. If you get those partially clogged nozzles, what we talked about, those fingering nozzles, don't be like those landscapers out there and dig your knife in there. You've destroyed the opening of the nozzle and you've ruined the efficiency. Just buy a new nozzle. Okay, so when it comes to your heads not popping up properly, the first question I would ask, is this a brand new system that's never functioned, or is it an existing system that used to work but now doesn't? If it's a brand new system that has never popped up correctly, it's probably a design error where people are trying to run too many sprinkler heads at once based on the size of pipe they have. Whenever you move water through pipe, you lose pressure. And if I try and add 6 more sprinkler heads to a system that was already working, this pipe cannot now grow to carry more water. Water has to move faster and faster and faster through the pipe in order to try and make up that increased demand. The faster you run water through pipe, the faster you lose pressure. So make sure you've got your pipe sizing done right. Now, if it is an existing system that used to work okay, but now all of a sudden doesn't, you've still lost pressure somewhere. So unfortunately, some people will use those flow control knobs to reduce excess water pressure that we'll talk about in a little bit here. That's a bad way to do it because it can't respond to any changes on your incoming pressure, and your incoming pressure from your water provider can change over time. Especially if you were one of the first people in that subdivision, you had that 12-inch water pipe all to yourself, and then the other 3,000 homes got built behind you. Now you're sharing that 12-inch pipe and you don't have as much pressure as you used to. That's why in general you leave those flow control knobs up. The other thing that could be happening is all or most of those wiper seals are leaking. And this particular brand of head, it's real visible what that wiper seal is. It's that white ring around there. So if all of those are leaking a little bit, you don't have enough pressure to get that thing to fully pop up and seal the way it should. Could be the water supply at your backflow. Somebody's got it partially shut off. Not all the way. You can still get water through there, but that restricted opening is now burning off pressure. The last thing that might be happening out there is sometimes as we move through the system, you'll see the pipe goes in here at 3/4 inch and comes out at 1/2 inch. May have been a piece of decomposed granite that rolled along inside there and now got stuck in that one spot. So these 2 sprinkler heads work, these 2 don't. Somewhere in between there is where your problem is. It's the last thing I'd look for because that means digging up the pipe. One last thing to talk to you about here is we talked about not using those little short 2-inch pop-up heads. Well, sometimes people do that because they realize they can use a real short riser and they don't have to dig the trenches deep to put their sprinkler heads in. So now you know you want to use a 4-inch sprinkler, but if I try and do that on that shallow pipe, it's now sticking up above the ground. So you think you're stuck at that point, but not really. What you do want to do is use a different way to attach your sprinkler head. So you'll see this device I've got here is called a swing joint. So you'll see it offsets the sprinkler head to the side of the pipe. There, you're not working right. There we go. So got all turned around in my box. So you'll see it actually offsets the sprinkler head to the side of the pipe itself. And now I can have the sprinkler head lower than the pipe itself. It also gives me flexibility. It also means that if I've got a tipped head because somebody glued in my fitting crooked, I can fix it. All 3 ranges of motion here. That actually runs you about $1.50 to $2 per each sprinkler head. It's really the way you want to go. Last things we're going to talk about here. Let me run through my presentation here real quick and make sure I haven't missed anything. Okay, last thing we're going to talk about is bubblers. Why aren't they bubbling? Well, these guys are super simple. When they're clogged, these are always sticking up above ground. All you got to do is take off the clogged up bubbler, turn on the system. You don't have to worry about keeping that stem held up because this is always above ground. Flush out that pipe. And there is a screen down there, but it got buried down inside there, so I can't get it out. I'm going to have to push that out one of these days. But again, put in your new screen. You should have a screen there to protect your bubbler and screw it on. And that's about all there is to it. So the last thing we're going to cover here for just a couple more minutes is pipe repair. So when you're gluing PVC pipe together, so we're putting in a new coupler here. Well, let me do it with this smaller piece. You want to make sure you are inserting that pipe fully inside there because inside that fitting is slightly tapered. So they do make that glue out there. They call it the blue glue. So you don't need to use that purple primer. I prefer to use the purple primer, especially for repairs, because what that primer does is it cleans the pipe. Make sure it's good and clean to make that solvent weld is what we call it. So I'm going to take some primer and I'm going to rub it inside the fitting. I'll put some primer on the pipe itself, make sure it's clean. That also pre-softens the plastic because what the glue does is it melts it together, what we call a solvent weld. So then I'm going to take my glue on a nice thin even layer. More glue is not better. And then I'm going to swab it inside here. And this is where you want to work real quick. And then you want to shove it in there and make sure you get it all the way in. And if you're not completely held on both sides, if you can, give it about a half a turn twist. Hold it for about 2 to 5 seconds because it is tapered. Until that glue sets, if you let it go, it'll push out a little bit. And as soon as you turn it on, you've got a leak. The other thing is remember, I've got to get this all the way in there. So now how deep of a trench have I got to dig to make sure I can flex this pipe up enough to get it back inside that fitting? Well, there's some great repair couplings out there. And one of them is a telescopic repair coupling, often called a slip fix. So what I'm going to do is I'm going to glue my regular straight fitting on here. I'm going to glue my slip fix on there. And then I'm going to have the other side of my pipe at just the right distance, because there is a spot for the pipe to meet up there. That just extends out to meet it. And this does allow you to do that twist. So some people will say, well, you got to make sure it's extending in the direction of the water. That's ridiculous. If you've got a good glue joint on both sides, you're fine. But it is very important that it is fully extended. If you only partially extend this, it does not make the seal, and you've got a leak right here. It's not a huge leak, but it will leak every time you run the system. So some of your landscapers out there don't generally use these types anymore. These are called compression couplings. And what's going on here is it's just a larger size fitting. And inside it's got these big rubber grommets. So what I would do on this one, so I would put a little threaded cap there. I would put on my grommet. And I would glue the pipes back together until they were only about that far apart. But before I do that, make sure you put this piece back on. Otherwise, you're cutting the pipe and starting all over again. And then you're just going to kind of line it up so that gap between the two pipes is in about the middle of this fitting. And then when I tighten this down with some wrenches, that is a good waterproof seal. So you'll hear some contractors say, well, I don't like these because that rubber sooner or later is going to deteriorate. That's true, but that's a really sizable piece of rubber. You're talking 20 plus years before that thing fails. And what really amuses me when those landscapers say that, inside here to make that seal is a very thin little O-ring, which is much more delicate than what you see in those compression couplings. Both ways work perfectly well. One last thing I want to give you a tip on your PVC pipe. Don't use hacksaws. You can't make a nice straight cut, especially me. I've got a dull blade. It never cuts straight. Buy an inexpensive pair of ratcheting PVC cutters. I'm going to put it on the pipe here. And it's kind of hard to do when I'm holding it up so you can see it in the camera. There we go. See how that naturally made a very nice straight cut, and it doesn't have all that fuzz in there that's going to get in the system. It's going to clog up my valve and cause it to stick on. It's going to clog up my sprinkler nozzles. It's going to clog up my bubblers and my drip emitters. Don't buy the super expensive ones. You're not using these all day, every day like a professional landscape contractor. Other thing on glue is I know we live in a Costco society. Don't buy the giant can of glue because it's 2 cents per ounce cheaper than the little can. The chemicals inside that can will flash off long before you ever need to use it again. It's time to dispose of that. Hopefully you have a household hazardous waste program in your city. You can drop it off there and go buy a brand new can of glue. The primer lasts a good long time. So let me check here real quick. PVC pipe. Okay, let's get to this here. Let me share the screen and we are just about done. Got about 2 more slides to show you. That'll take about 30 seconds. Oh, okay. So you need more help. This is a very shortened version of this course. Obviously, we can't expect you to hang around in front of your computer for 3 hours. I am nowhere near as entertaining as those Marvel movies, but there is good help for you out there. The irrigation supply stores, Ewing, Horizon, Site One, and Sprinkler World. They've got branches in all the different cities. Use whichever one you care for, whichever one's closer, which one you just like talking to the people better. I have nothing against the home improvement store products or their employees. I've been in the industry for 30 plus years. I know what to buy and what not to buy. Also, some of those guys in those orange aprons, they actually are pretty slick and pretty knowledgeable on irrigation, but sometimes the advice I hear being given out when I'm in there makes me think to myself, I bet he's really good at fixing toilets. He doesn't know much about anything on irrigation. The people who work at those irrigation stores have worked in irrigation in the real world. They're going to be a great resource for you. The other thing you can do is check your manufacturer's tech support lines and websites. I'm listing the websites here. I think you've got a newer version of the handout which should have those 800 numbers for you. Rainbird's easy to find. Hunter's a little more challenging, but your search engine of choice, Hunter and Irrigation, will get you to Hunter Industries. Toro's easy. Irrigation Systems. This company used to be under the name Hardy. Same company. They just changed their name. No big deal. You can find specifications on your products. How many gallons per minute does each nozzle use? You can download the manual for your timer because most of you don't have them anymore. So that way you can always refer back to that on things like your battery. That being said, I ran just about 5 minutes longer than I wanted to. But we're all set. Does anyone have any questions?
Thanks, Jeff. That was a great presentation, but it doesn't look like we have any questions. Sorry, Connie, I cut you off.
Well, another resource you have for you is your city water conservation offices that are listed here on the page with their contact information. Great resources for you as far as helping you figure some of this stuff out. They've got lots and lots of information for you that'll help you figure these things out.
So far, no questions, but again, like Jeff mentioned, our contact information is on the screen. If you do have questions later on, or you have a question that you can't seem to find the answer to on Google, definitely reach out to us. Oh, we have a comment. Someone says, thank you, Jeff.
Well, I hope it helped, or at the very least, I hope we've confused you to a higher level.
All right. Well, if no one has any questions, yeah, they said it was very informative and they really appreciate it.
Awesome. We look forward to seeing you in the real world face to face next spring if all goes well. Although yes. I must say, is from the presenter side, it's kind of easier for me to do it this way because when I'm done, my living room is right over there. I don't have to pack this stuff up and put it in my car and drive home. But I do think there is it's a lot easier for people to really understand when they get to actually handle the products and things like that. So we're really hopeful and looking forward to our spring sessions.
We have a question.
Hmm?
Are bubbler systems always PVC pipe? Is there a flexible pipe?
99% of the time, yes, they are going to be on PVC pipe. There are some components you can use with poly drip tubing that turns them into kind of bubblers. Many of you might be familiar with unfortunately, too many people call them adjustable emitters. And I only have my sprinkler stuff here on my table with me. But on your emitters where you've got the little caps that you can turn and they put out the fingers of water, those actually are not emitters. Those are actually made for watering things like flower pots and flower beds. But those are actually, the correct term for those is micro bubblers. That is one way to use drip irrigation to water your citrus trees, but be very careful. If you've got them wide open, any more than 8 of them, you've lost all your pressure in your drip tubing and you don't have enough for that last one to actually put out, except for a little bit of oozing of water. You can only get so much water per minute through that tubing, and if you try and go too far above that, you're just not going to have any pressure flow at the end of it.
All right, thank you. Anything else while we're still here? All right, well, we do have a quick survey when you exit the class. If you could just take a few minutes of your time and just answer those questions, it really helps us put on either new class topics, and it lets us know how we did and obviously how Jeff did too. So if no one else has any questions, then we will let everyone go and enjoy the rest of their night. All right. Thanks, everyone. Have a great night.